I don't know, it looks like a bento from Dunkin'.
Okay, we're videoing this class because we had a mishap in the other class. What happened? You don't need to know. Okay, we are class. The AMC 12B or 10 will be given on February 20th, which is a Wednesday. If you want a second chance to take the 3-hour test, sign up right here.
Well, does it come for the quiz?
You have to sign up by 3 p.m. today.
What cycle is it?
Well, it's 2 weeks from now, so what is this? So it'll be cycle 3
Quiz
then.
grade? Quiz grade? I agree.
No, because this is optional. This is only if you want
Wait, what
to
if we
take the
score
3-hour
higher?
test.
Can it be our quiz grade then?
No, because everybody got to take the same test.
Oh, so if it's 3,
Okay. Anybody else? Don't rush up here.
if it's 3 hours, how many periods do I get?
You missed almost the whole morning.
Wait, which cycle is
Oh!
This is not the 3-hour test. This is to qualify for the 3-hour test.
Oh, so.
Because some of you, if you didn't make the 100 on the first one, right?
it? I just want to go and just guess, randomly guess.
I'm not gonna miss all the boring class.
Yeah, but it doesn't count for quiz grade, so I wanted to do that, but then it counts for quiz grade, so I was like,
You
yeah.
have to send in those names today.
Wait, what
By
cycle
3
is it?
p.m. today.
What cycle is it?
Oh, oh, they'll send the scores like in
We're only going to miss the first class, yeah?
1 or 2 weeks.
I wasn't even close.
Okay, from now on, only the people without iPads are going to get anything.
Oh my.
You download the, I mean, like every time
Oh!
you have to open it up
Hey,
on the website.
the iPad Central people told me that's what the iPads are for.
Wait, how do you make it download?
We're going to go green.
You open it in Notability Notes.
What the heck?
So? I
I
thought Notability was only $5 or something. Huh?
$2.
Was $2. So there you go.
You can buy a hand roll. Sushi.
Yeah. Whatever, or go take it home and print it out then.
No, I'm just gonna print it.
Yeah, but if they catch you.
Wait, what?
If they can't get me
Oh,
angry.
yeah,
Really?
Yes. This is for you to go green.
I don't care what the environment is.
Oh, that's what they told me, the iPad Central people. That's what it's for.
No.
Oh, I thought it was
Next
for
year,
class.
there's not going to be anything. Nobody gets anything next year.
Why? Everyone can get iPad next year?
Yeah, 4th through 12th grade next
So
year.
there's a $500 technology fee
There's technology fee?
Yeah.
along with the $18,900 tuition.
Wait, so we're practically buying this iPad. And then we don't get the
Boy, how much is an iPad regularly?
like 500?
Really?
So
Yeah.
why don't we just buy it on our own?
Yeah.
That's
so dumb.
Because not everybody would buy it.
So they're forcing us to pay for it?
And then not keep
Well, they
it.
better buy
So
it.
they're making profit off
No,
off
but
us.
it's not just that. Because what about the insurance that you got to pay for too?
Well, they still charge
Because if you break it, then you just pay the deductible, right?
Try not to break it.
Of course everybody's going to try it out.
I try not to break my phone.
Okay, today we start the next chapter. Okay, I'm just warning you, the next 2 chapters are very difficult.
I should have dropped
Everybody move back a foot. Let's just keep creeping closer and closer to the
When
board.
do we get new seats? Hey, I want a new seat. The seats go bad.
And you have to order this.
Super badly on.
Wait, yeah.
Oh yeah, the seat's full.
It is, like,
Well, then why don't we get
when I was sitting there, I used to do well. And then now I moved here, like, I can't think anything.
See, you can't even think of that. Okay, so this chapter is on vectors. Now you guys in physics think, oh, I'm already good at vectors. Well, you guys only do baby vectors. Now we're going to do man vectors. And the next chapter, I'm pretty sure nobody has seen before. It's called parametric equations.
Oh, it's like paramedics.
No. And that is typically the hardest chapter of the whole year.
I thought using conic section was the hardest.
Up until that point.
Oh my god!
No, all the high part stuff come in the second semester.
Wow.
The first semester was review.
I should have aced this test.
That's what I told you guys. Okay, now in mathematics there are two kinds of quantities. There are scalar quantities and vector quantities. Now you guys in physics, you guys know that a scalar quantity only has magnitude.
Direction doesn't matter.
Yeah, direction doesn't matter. Let's give some examples like mass. Come on.
Speed.
What? Temperature.
Speed.
Speed. Work. Who said work?
It says it right there.
No, you're supposed to know it. And that's probably the most important one. Work. Okay, who's in physics? Then you guys know work is a scalar quantity, right? F d cosine theta.
What is work?
The number or the amount of force you put into a
To move something a certain distance.
Force equals mass times acceleration.
Okay, but a vector quantity not only has magnitude, but it has direction as well. So velocity, acceleration, force,
Power is a
momentum, torque. These are all examples of vector quantities. Now, since a vector has magnitude and direction, the best way to represent it is by an arrow. The length of the arrow is the magnitude of the vector, and of course the direction it's pointing is the direction. So we're going to start with 2 dimensions. Okay, then we're going to go on to 3 dimensions and higher. Now, if the real world is 3 dimensions, why do we even bother with 2 dimensions? Why don't we just start learning 3 dimensions from kindergarten? Because it's difficult. So that's why we study 2 dimensions first, because it's easier, but then when you make the transition from 2 to 3 to 4 and higher, then a lot of the formulas are very similar, as you're going to find out in this chapter. Okay, now in books, if you guys read books, vectors are denoted with bold-faced letters, yeah? You guys in physics. Bold-faced, you guys know what bold-face is, right? Bold-faced letters represent vectors. But it's humbug to draw it bold-faced, so we usually just go V with an arrow over it. So if you don't have the arrow over it, it's not a vector now. Anyway, just like matrices and determinants, some of you still don't know the difference between the brackets and the straight bars, I noticed on the test. There's a difference. There's a difference between this and this.
Oh.
That's a scalar, that's a vector. You've got to put the arrow
Wait,
in.
wait, what?
That's scalar quantity. This is a vector quantity. Okay, today we're only looking at the basic operations of vectors, okay?
Oh, do you only put one part of the arrow?
Wait, let me look. Yes, because it points from one place to another.
I mean, like, there's only like top.
Well, if you want to do this, you can do this if you want, but that looks so, what's the word I'm thinking of? Hokey.
Hokey?
Hokey. This looks more streamlined. You know what I'm talking about? Hokey. You know, like
Like hokey pokey.
hokey. So archaic.
Okay.
Oh.
Whatever. It just doesn't look.
Trendy.
Yeah. Okay, now we're gonna learn how to draw vectors. Okay, if this is vector v right here, what if I ask you to draw 2 times vector v? What would you do?
Just extend your line.
Yeah, you make a vector that's twice as long as this, and it points in the same direction, so it's gonna look something like this. What if I ask you to draw -1/3 vector v?
You go to
You
your
draw a vector that's 1/3 as long, but it points in the opposite direction, so it's gonna look something like that. Hard to draw it exactly, right? Yeah, but even if a ruler, that can be exact, right?
Does the angle matter?
Yes, it's gotta point in the exact same direction. Okay, now, so we know how to multiply a vector by a number now. Oh, man. Okay, good thing we didn't take the other classes. Forgot to do something.
Oh,
what's your
That's okay, they can read the notes.
But do you use that?
Yes. Oh, there was a mishap in period 3.
Oh my god.
what happened?
I'm not gonna tell you, it's just a mishap.
Wait, how come the thing's so blurry now? Like when I tried to watch it on YouTube, like it's so blurry. I can't.
Really?
Yeah. Like,
Yeah, it was really
It's blurry?
Yeah, I can't even read what you're writing half the time. So
Just what, the past few days?
no, like matrix 2, 3, and 4.
Really?
Yeah.
Maybe it's the camera then.
You have to buy a new one.
Yeah, I think we need a new
Use the
camera.
iPad.
Yeah, iPad cameras are so good.
Okay, but how do I get the, where do I put the iPad so that it,
You have
oh, the music stand.
Yeah. No,
Or
it's
you have
heavy.
some music stand.
Or just like
Really?
stick it
Can I
on
get
there.
one?
That's it. Yeah, but then on the iPad, doesn't it not zoom in and out?
It does.
Does?
Yeah, it
Not
does.
video.
It does. It does.
No, only the camera zooms in and out.
I'll bet you 2 points.
What?
Like when you're watching the video that you took, you can zoom in.
Oh, when you're watching it.
No, you can zoom in. Look. Oh, you can't. What the heck?
What I said. I don't even know anything.
Take a picture, take it.
Don't you dare.
No.
Okay, can we move on? Okay, now how do you add two vectors together? You guys in physics are good at this, right? Let's say this is vector A. Ooh, that's ugly. And this is vector B like that. How do you add these two vectors together?
Get the rectangular
Okay,
form.
so you take vector A. Now, when you work with vectors, you can put them anywhere you want in the plane as long as they point the same direction and has the same magnitude. Okay, so here's vector A. Now you take the tail of vector B and you put it at the head of vector A, so like this. You guys learned this in physics. Okay, whatever, well, I'm teaching you now then. Okay, and then you draw a new vector that goes from the tail of vector A to the head of vector B, like that. This is vector A plus B. That's how you add vectors together. You take the first one, you draw it. You take the tail of the second one, put it at the head of the first, and then make a new vector that goes from the tail of the first to the head of the second. No, that's not how, well, you don't know that's a right angle. It could be a right angle, but we'll learn about that later. How do you tell if it's a right angle?
Well, you subtract the
No, I'm
average.
not asking. That we'll answer that question later, okay?
That's a rhetorical
Because we have to know
question.
something. So that's how you add vectors together. How do you subtract vectors then? Well, if you wanted to draw a vector that's A minus B, well, by definition, that's vector A plus negative vector B. So you take vector A, make sure it points in the same direction and it has the same length. Then you take negative vector B. Well, if this is vector B, negative vector B has the same length, but it points the opposite direction. You take the tail of that vector, put it at the head there, and it goes like this. So this is A, and this is negative vector B. So if I add those two vectors together, that's A minus B. And that's how you subtract vectors. So for those of you without experience with vectors, you guys in chemistry now, in physics, this is old hat, right? This is second nature already. You have to know that this plus this equals that. You gotta be able to do that. So if I give you a picture, let's say I give you this. Toot. 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 If this is A, B, and C, what plus what equals what?
A plus B equals negative C.
No.
A squared. C plus A equals B.
C plus A equals B.
Oh, I see.
So this plus that equals that. You gotta be able to see that.
Trick question.
Yeah.
If it's A plus B or C.
No?
Yeah.
No, it doesn't. A plus C equals B. But then normally when you add, this is the first one, then you put the tail of the second vector at the head of the first, and then it goes that. So you guys in chemistry, you gotta get this down. This is super important. Anyway, last year they told me, the guys in chemistry told me we learned it in chemistry anyway. Something about the angle of water, something that vectors make 120-degree angle.
We just
touched
skimmed
upon
on it, but then she didn't.
We didn't learn anything. This one is right. And we have.
Yeah, talk about it.
Yeah, you wanna say it on the camera?
No, I'm still wearing good terms now. She's like, Ashley, you're a good student.
Okay, fine. Okay, now, can you see it's kind of humbug to keep drawing these things? Is there a way to work with vectors so we don't have to draw pictures all the time? You guys in physics, you guys know this. It's called
Rectangular form.
componentizing.
What the heck?
Okay, so let's say you have a point in the Cartesian plane, A, 2, 1, and you have a point B in the Cartesian plane, 6, 4. What if I draw a vector that goes from point A to point B, like that?
That's a 5.
No, let's componentize this vector. So it's important to know that the vector goes from A to B, so it's like this. You draw it like that, from A to B. See how the A is at the tail and the B is at the head? Because otherwise, if you go the wrong way, that's a different vector. It's pointing the opposite direction. So how do we componentize this? Well, it's simple. You just make a right triangle like that. We call this the x component because that's how much you go left and right. And this is the y component. So how much do I, if I go from here to here, how far did I go?
4.
And then from there to there? 3. So the component form of this vector is written like this. This means the x component is 4 and the y component is 3. In other words, to get from this point to that point, you got to go 4 to the right and 3 up. What? Look at the note. Component ties. What? What? Yeah, we're not there yet. Yes, it's a 3, 4, 5 triangle, okay, but we're not there yet. I want you guys to learn how to componentize vectors. So, Mr. Park, just draw this right triangle all the time. Okay, but what about when we get to 3 and higher dimensions? What are you going to do?
Draw cube.
You gotta know. Okay, what about 4 dimensions then? Draw a hypercube.
Yes.
Okay, be my guess.
Be my guess.
No! Look, if I want to get the components right, you simply gotta go head minus tail. Right? Just like if it's on a vertical line, you go right minus left, horizontal line, right minus left, vertical line, top minus bottom. So if you want to get the components right, you just go simply head minus tail. 6 minus 2 is 4, 4 minus 1 is 3. That's correct. So now we don't even have to draw pictures anymore. What if I give you 2 points? Here's point C. Oh, just we don't draw a picture. What is that? Give me some coordinates. 3, -1. Point D is
21,
no.
7.
No, come on. 7, comma
2.
2. Okay.
Yeah.
Componentize vector DC.
4, 1, 3.
So you go head minus tail.
Head is C.
This is the tail because see, D is at the tail.
Head minus
C is at the tail. You gotta go head minus tail. So you gotta go this minus this. 3 minus 7.
Negative 4.
-1 minus 2.
Negative 3.
Okay, so that means to get from point D to point C, you have to go 4 left and 3 down. In other words, the x component will be negative and the y component is negative. So that means the vector, you gotta go 4 left, 3 down. The vector looks something like that. What?
Negative.
It just tells you how to get there.
Nice.
How do I get from this point to that point? You go 4 left and you go 3 down. That's what it means. Now, I just want to let you know, this is not the only way to componentize vectors. This is the way mathematicians do it, but when you take physics and engineering, you write it like this. 4i hat plus 3j hat.
Oh, that's
Hat.
what we did in matrices.
No. No, what?
Yeah, we did.
No.
Oh,
We didn't do any hats. It makes you anything like
but we
that.
did
Anyway,
5J.
this looks exotic, maybe for you even erotic. But all it means is the x component is 4 and the y component is 3. That's all it means. Oh no. So like over here, what's the other way around? -4i minus 3j. Now when I write my vectors, I do it either direction.
No, I'll let you take this.
Okay, I didn't. Never mind. It just rhymed with exotic. You guys gotta get used to both, though. Okay? I don't know. You ask them. Okay, now you guys in physics. If you are given a vector like this, what does this mean?
Absolute
value.
No, it means the magnitude or the length of it, not absolute value. How about determinant then? No, because it's not. Oh God. It means the length of the vector. So here's vector AB like this. Look, it has an x component of 4 and a y component of 3. What do you think the length of it is? 5, because it's the length of the hypotenuse of the right triangle. That's all it is. So in general, if you are given a vector, a two-dimensional vector, here are the x and y components, what's the fast way to compute the length?
A
Yeah,
squared.
square root of a squared plus b squared, because that's just the hypotenuse of a right triangle, right? Okay, now the reason, okay, this is what I forgot to do in another class. The reason that we put vectors in component form is now it's so easy to work with vectors that we don't have to draw pictures anymore. Let's say vector u is equal to, give me some numbers, 2, comma, negative 3. Vector v is equal to negative 1, comma, 5. Okay? What if I ask you, what is 3 times vector u without drawing the picture? Now here's vector u. What do you think 3 times that would be? 6, comma, negative 9. See, there it is. Doesn't draw a picture anymore. It's a vector that has an x component of 6 and a y component of negative 9. So 6, negative 9. So something like that. But we don't need to draw it anymore. Now, what about adding vectors? What is vector u plus vector v? Now, you guys in physics know this, right? To add two vectors together, what do? You add the x components, 1, and then you add the y components, 2. Finished. Yeah, so if it's a component form, you don't have to do this thing anymore. This plus that equals that. No need, you just do this. What about vector v minus vector u? Yeah, you just subtract. So this minus that. This minus that. No, it makes a difference because your vector is going to point the wrong way if you do it like that. And then, of course, once you have it like this, what would be this? V minus u with the bars around it. What does that mean again? The magnitude of the vector. So without doing any pictures, what is the length of this vector right here? It's the square root of that squared plus that squared. Can you do that again?
73.
Root 73. So easy. And that's why we componentize vectors, because we can work with them without drawing pictures anymore. Because you guys have problems drawing pictures and graphing. Because what happens when you get to 4 and higher dimensions? Very difficult. Even 3 dimensions, you guys are going to have problems drawing pictures. That's why we got to be able to work with this without drawing pictures. Okay, now let's do a problem. I'll do a problem from the homework. It's almost exactly, so I don't want to, and it's in the notes. I don't want to see anybody writing this on the board on Monday. Let's say you have an airplane. It's flying due east at 400, no, tonight's homework is 400. We'll make 500 miles per hour. And then it encounters a wind. The wind is blowing southeast at, tonight's homework is 50 miles an hour up to 60 miles an hour. So what's going to happen to the plane when it encounters this wind? Yeah, it's going to move the plane, right? It's going to change the course of the airplane. So basically, you just add the two vectors together because this is like the velocity vector of the airplane. This is the velocity vector of the wind. If you add them together, you get that, right? This plus this equals this. We call this the resultant. You guys know that in physics, right? Resultant means the sum of the two vectors. Okay, so here's the problem. You got a plane traveling 500 miles per hour going due east, but it encounters a wind blowing southeast at 60 miles an hour. What is the new speed of the airplane, and what is the direction? Two ways of doing this problem. Once we did this in period 3, and we did the first way, and we forgot to do the second way. That's because they don't say anything. Okay, now, if this plane, okay, what we want to do is find that, because the length of this will give you the new speed of the airplane, right? How do I find that? Well, if the plane is blowing, I mean, if the wind is blowing southeast, doesn't that mean this is a 45-degree angle?
Yeah.
So, southeast means halfway between south and east. So this is a 135-degree angle. If you know two sides of a triangle and the angle in between, how do you figure out the third side? The law of cosines.
Oh,
So x squared equals 500 squared plus 60 squared minus 2 560 cosine 135 degrees.
Oh my god.
So we still gotta know law of sines and cosines? Yeah, and if you look at the first page of the notes, you gotta know determinants too. Look at it, we got determinants there. That's why we learn this stuff so we can use it. What do we learn it for? So we can just forget
Should
it?
we get a calculator?
Yeah, we have to use a calculator.
So we can get cosine.
So the period 3, I had to get out my calculator because we couldn't do it on our own. So let's do this. 500 squared. I'm putting my calculator in degree mode. Plus 60 squared minus 2 times 500 times 60 times the cosine of 135 degrees, katouche, and then we gotta square root that. So square root answer, and I get x equals 544.083, rounded to 3 decimal places. And since I'm gonna use this in another computation, I'm gonna store it. I'm gonna store this in,
A. X.
yeah, I was thinking x, since we called it x. But it's up to you. Okay, there you go. So the new speed of the airplane is 544 miles an hour above. Does that make sense? Yeah, because part of the wind is pushing the plane that way, right? Part of it. Okay, now we gotta find the direction of the airplane. So let's call this angle phi. How do I compute this angle phi? Law of sines or law of cosines?
Sign.
Now what did I see? You guys don't listen. When do you use the law of sines? When you know 2 angles in a triangle. Do I know 2 angles?
All cosines.
Good. Yes, however, can we say for a fact this angle is less than 90 degrees?
Yeah.
Yeah.
Yeah, so then you can use the law of sines. So sine phi over,
Wait, why is it
call it whatever you want, theta?
Oh.
I like phi.
B?
Sine phi over 60 equals sine of 135 degrees over x, which is stored in my calculator now. So therefore, sine phi is equal to 60 sine 135 degrees over x. Okay, let's punch that in on my calculator. 60 sine 135. You're just going to let me do all the work here. Divided by x equals, and then I got to inverse sine that. So inverse sine answer, and I get phi equals 4.472 degrees. That's this angle right here. So now you got to give the direction. So what's the direction? Give a direction. What's the direction?
East.
South.
It's 4.472 degrees
South of east.
south of east.
Wait, I don't understand. How you-
Because this is east and you're going south of east. See, south of it. But for
No, but how did you get the 4.4?
compute this number and then inverse sine it.
Oh, I forgot to divide by X.
Or if you want to, you can say 85.528 degrees north of east of south. But why? Or you can just give the course heading. You guys know what a course heading is?
350.
A course heading is always measured from due north.
Oh, yes.
So measured clockwise. So the course heading would be 94.472 degrees. That's the course heading.
Wait, why not this way?
Because it's standard navigation. Course heading means from the north going clockwise. So if your course heading is 270 degrees, which way are you going?
Left.
You're going west. Not left. You never come to be a navigator. If you're facing like this, if you're in disorientation. It all depends on your orientation. You guys in physics should know that, right? Okay, this is one way to do it. The other way is componentize. Okay, here's the velocity vector for the airplane. Componentize that. If you want to set up a coordinate system, but we really don't have to. Look, this vector is pointing directly east, right? To the so what? What's the x component? 500, comma 0, right?
Settle.
To get from this point to this point, you go 500 to the right and none up and down, right?
Yes.
Okay, componentize this vector. Yeah, look like that.
Cosine.
It's a 45, 45, 90 triangle.
60 cosine 45.
Okay, this is 60 So this would be 60 over root 2, and this would be 60 over root 2, because that's a 45, 45, 90 triangle, right? Okay, so what's the x component? 60 over root 2. What's the y component? Negative 60 over root 2, because you gotta go right and then down, right?
Right.
Okay, so just add these two vectors together. How do you add two vectors together? You add the x components together, and then you add the y components together.
Yeah, 500.
What? Where? It is 500. Okay, now that is this new velocity vector over here. How do you find the length of that vector? Square root of this squared plus that squared. So 500 plus 60 over root 2 squared plus this thing squared. Negative 60 over root 2 squared. Compute that on your calculator, and you know what you're going to get? That. 544.083. I'm not going to do it. Now, what about the direction? If you are given the components of this, how do I find this angle here?
Tangent.
Yeah, just go tan inverse the absolute value of that over that, right? Y over x. Look, you make a right triangle right here. Opposite over adjacent is tangent, right? So which way do you like better, doing the log cosine way or just componentizing? I don't care which way you do it, they both come out the same. For those of you who were trained in physics already, you probably used it this way already, yeah? Most of you are in physics right in this class. Because in period 3, not one person is in physics. Not one person.
No, they are.
No.
Not one person.
Yoshina is in physics.
She never raised her hand.
Yeah.
Yoshina
Sorry, Zang.
and Zhang.
Oh, Zhang's in AP. No, she's not.
They led me to believe that nobody in this class is in physics.
Or
I'm
Casey.
honestly enjoying it.
Yoshina and Zhang.
Bro.
I'll make corrections.
Prepare for castration.
Oh,